Hello, folks. Now we're coming to the end of the semester. This is going to be working on our last unit, which is magnetism, and this is the first problem set we're going to be working with today. So, in problem set A for chapter 19, we're going to use this equation: F is equal to BQV, where F is going to be the magnetic force, and this is going to be in the units of newtons. B, the magnetic field, that is going to be Tesla, capital T. Not the car, folks. This is the magnetic field, and this is the magnetic force. The charge is the charge on the particle, and then the velocity, and V is the velocity of the particle, right angles or perpendicular to the field. So we got this at right angles to the magnetic field. We got the charge. So if we have the field, and say the field's going this way, we're looking at a particle with a charge on it. Let's call it negative, and it's going to go through. It's going perpendicular through the field. And this, when it does this, we'll have a force. And this is what we're going to be that we talked about in the previous slideshow for this week. So, fairly simple. F is equal to BQV. So, for this example, we have, notice a bubble chamber is a device. All this is background. Meaning that we're trying to give you an idea of what's happening, why we're doing what we're doing, but to answer the question, you really don't need this stuff. Suppose a proton, okay, now that's interesting. We got a proton travels in these bubble chambers, and this, we have a speed, that means we got a velocity, and magnetic force, and we got magnetic force. So we want the magnitude of the magnetic field. So we're looking for B. So this is B, this is F, this is velocity, we need charge. The charge of an electron is negative 1.6 times 10 to the 19. Since the charge of a proton and electron are similar in magnitude, the charge of a proton is equal to positive 1.6 times 10 to the minus 19 coulombs. All right, so let's go ahead and try and solve this. So F is equal to 4.3 times 10 to the minus 12 newtons. Q is equal to positive 1.6 times 10 to the negative 19. And that's going to be coulombs. And then the velocity is 1v is equal to 1.9 times 10 to the 7th meters per second. And at this point, there are no conversions to do. Everything's in the base unit that we need. So the equation, force is equal to B times Q times V. And what we need to do is we want B. We got three other variables, so this should be an easy algebra manipulation. Take Q and V, divide both sides by Q and V. So F divided by Q over V is going to equal our B, which is our magnetic field. So let's go ahead and substitute all the numbers in. 4.3 times 10 to the minus 12 divided by 1.6 times 10 to the minus 19 times 1.9 times 10 to the 7th. And that should give us our magnetic field in B. So let's go ahead and do the mathematics. So I'm getting my handy dandy calculator out. You guys should have one too. So 4.3 raised to the negative 12 divided by the quantity of 1.6 raised to the minus 19 times 1.9 raised to the minus 7th to, oops, positive. That's positive 7, guys. Don't make the same mistake I did. And when we solve this, our magnetic field, B, our magnetic field, is going to be 1.41. And that is going to be Tesla. So that is the answer for this. Guys, for our equation, to finish up, remember force is equal to BQV. You should have all the variables but one in each of the problem sets, and all it is basically simple algebraic manipulation to get the variable that you're looking for.